reactions. Alright? So we can move on from addition polymers to condensation polymers, right? Condensation, polymerization, right? And we have three of them. Three general types, right? We have the polyester, the polyamide, and three, we have the polysaccharide, right? Alright, so polyester, right? If you remember from last week class, we said that when an organic acid react with alcohol, we form an ester, right? So we know the functional group of ester from last week. So ester is C11O. That's the ester functional group, alright?
I remember right.
The amide functional group, that's for the amide. Right? Remember, in this case with the amide, nitrogen will have 3 valence in it. It forms 3, it have 5 valence electrons, but it will have 3, can actually form 3 bonds. Around 3 bonds. It have the space to form 3 bonds. Just like our carbon have 4, nitrogen have the space for 3 bonds, oxygen 2. Alright? So this would be the functional group, the structure for the amide. Okay? Well, the polysaccharide in the exam, if you are representing it, is it's normally just they represent it like X, O, Y, and you will see why, because polysaccharide is basically different alcohol molecules joining together. One alcohol will lose the OH, the next one will lose just the hydrogen. Alright, but we'll look into that shortly. Alright. It's gonna be the unit, alright? Good. So these are the functional groups for a new molecule, right? Now, but as you know, with the polymers or the condensation polymers, we'll have to have diacids and dialcohols, right? So both ends will have of the monomer will have to have functional groups that can react. That's the only way we would have the possibility of making a long chain of the molecules via condensation. Because if it has just one acid, say for example we using the polyester, right? Let's look into it directly. So you have this from the board, right? So you have the three different types of condensational polymers and you have the functional groups that we'll be looking at, right? So let us look at them one by one, right? So the polyester. Polyester, right? So the monomers, the dialcohol plus a diacid. Alright? Polyester example, real life example of polyester. So these are made like the soft drinks bottles are polyesters. So it is polyethylene, PET. You can research what that stands for your assignment. And terylene. And doctor. So in general, all these materials they are used to make the PET is used to make the bottles for drinking soda, so that are soda bottles, and they are also used to make fibers for clothing, boat sail, etc. So those are stuff that you can go and read about. But those polymers they used to make, right? But I'm not going to give you the specific example of them because these are very large examples, right? So I'm just going to give just for exam purposes, I'm going to show you how 3 small dialcohol and diacid, well 2 dialcohol, 1 diacid could come together to form a polymer, alright? With condensation in that sense. So we have C. Alright. Alright. And then another molecule over here, right? Right? So this is a diacid. This is a dialcohol. This is another diacid. Right? In the exam, for the condensation type, they may just ask you to use 2 molecules to show it. Alright? So, but I'm going to show you 3 of them. Alright? So in this case, O. Alright, now, whenever you have an acid react with an alcohol to form the ester, the OH group that is going to form the water after condensation. The OH is taken from the acid component and the hydrogen is taken from the alcohol. So whenever we have a condensation polymer which is a polyester, it's between a dialcohol and a diacid. But I'm telling you that reviewing the reaction of the alcohol and the acid to form an ester, the OH is coming from the acid, the hydrogen is coming from the alcohol component. Okay? So we will have here So this O here would be from the alcohol, C, that's an H there, H, right? So this would be one unit that is here, alright? Now this, over this side will be O here, as you can see. We're here, so 1, 2, 3, 4, 5, 6, right?
Do that again.
So this is 1, 2.
1, 2. I say the O.
Yeah, because I'm putting the bracket here, because remember that the acid always lose the OH. So if we're representing a unit, we're going to remove the OH and just leave the stick here.
Okay.
Good? So this is the ester unit there. All
So
right?
you lose the OH after that.
OH from this,
Yeah.
the hydrogen from this.
Okay.
Alright? Then over here we'll use the hydrogen here, then we're going to lose this OH. So this is going to go here. So C double bond O.
Okay, look at that.
Alright? And then that would be our representation. Alright?
We get to this, please.
Alright. But however, as I said before, when you're doing the condensation polymers, most often than that they just want you to show 2 repeat units. Alright? They don't have to throw them all of 3.
And the acid again.
Yeah.
You just want to get this so that minutes throw so much like it.
Alright. So remember that the example that I'm using here, it's not PET nor Terylene nor diachronic. These are just some examples. I'm just using a simple molecule to show you, right? However, in real life, they could just use like an X or a Y to represent the alcohol or the acid in bracket. If you should take a note how they set it in the book, alright? So I'm just using a real possibility here that could potentially be given in the exam.
Sorry.
Polysaccharide, alright? And then we can go through the questions.
So you lose the O3 and the acid and the other end. You lose that as well?
Yes. Because remember that all times when we're representing the polyesters, the OH from the acid will go. Alright? So here is gonna plus a water here. So this goes as a water molecule plus another water molecule here. Right? So these are like small byproducts from the reaction that from polymerization reaction. So it will, the solution, the reaction mixture will give off water as byproduct.
Okay.
And that is why the term, it's a condensation polymer, meaning you lose a water molecule
You lose water molecule.
during the reaction process. Unlike addition polymers, which you would really lose anything, all the monomers will just come together to form the polymer, right? Or the plastic. Right? And polyamide, you have both synthetic plus natural. So you have example, you have nylon, which is synthetic, and you have proteins, natural. Right? So for polyamides, we have both synthetic and natural examples of polyamides. Right? So you have to bear that in mind. If we look at polyproteins, the monomers are amino acids, and you should know the example of amino acids. So poly, so proteins, monomer, amino acids, right? And the general formula for amino acid So this is the general form of our amino acid. So if we move from one amino acid to the next, so we have about 20 amino acids. The only difference in the amino acid would be R. So R is a hydrocarbon, or it can be something else. So this can be hydrogen or a hydrocarbon or another group. Alright? So we're R, hydrogen or alkyl, or another functional group, or another group. Alright, so this R can be hydrogen, it can be CH3, it can be CH2, CH2, CH3, etc. And all this will give the different names of the different amino acids. So C, R, H, plus R prime, just so that they are may or may not be different, same group, alright? But most often than that in proteins, naturally occurring proteins, there will be a mixture of amino acids.
Okay.
So proteins will not just be one type of amino acid, they will be all mixture together. Let's put this one here. It's not really fixed, it's the same thing, but just let's keep it consistent like the book, right? I'm going to show a unit of the polymer that's a protein. Alright, so this is one amino acid reacting with another amino acid. Right? That does this, and then you're going to form so this OH will go from the acid here. Alright? C H R N. No. This is how this reaction goes. So the amide group here will lose the hydrogen. So it's a similar scenario to the alcohol, which the hydrogen come from here, and in all cases the OH will come, the OH in the water will come from the carboxylic acid. Alright, if you notice, same principle again, the OH come from the carboxylic acid. So here we have a hydrogen here, but this one would go, so this would form to this double bond O, so plus a water here, which is lost. We are at this carbon, so we'll go to another carbon with R prime, N, H. That's a unit for a protein, possible protein polymer.
I can mix out other.
You can remember that the amino acid will have two carbon here plus a nitrogen here.
Okay.
Is the stuff. But I'm saying that this group here, this don't have to be a hydrogen, it can be a hydrocarbon, or sometimes it can even have other molecules.
So when the reaction is taking place between the amino acid, that's two of them is amino acid, right?
The amino acid meaning have an amino group, which is an amide, and it have an acid group. That is why the name amino acid. That means it have both amide and acid group in the molecule. Okay. Right?
So you say it lose the hydrogen.
Yeah, the amide aspect will lose the hydrogen, or the amino aspect will lose the hydrogen, and the carboxylic aspect lose the OH as usual. Definition of polymer, general group is the polysaccharide, right?
And that loses the hydrogen at the end of the amino.
What?
That one loses the hydrogen.
Yes, it will lose the hydrogen. Here.
just say stop at the end.
So, final type of condensation on polymer is the polysaccharide, and they don't have any synthetic form of polysaccharide. It only exists naturally, right? And examples are starch, glycogen, and cellulose. Right? So starch, as we know, we'll find this in the ground provision. Glycogen is in the polysaccharide found in humans for storage, like in the liver. And the cellulose would be like also in plant as well for the cell wall. Good. Alright. So monosaccharides are the monomer. Monosaccharide, and the example of a monosaccharide is glucose, right? Which is C6H12O6, right? Normally, you can, again for your homework, you can go and look at the structure for the glucose, but in general, in the exam, we would just let, like, represent glucose, because in general the polysaccharides, the monosaccharides, they're all polyalcohol, so it's just basically carbon, hydrogen with lots of OH groups on it.
Alcohol.
Good. So for example, you'd have like C, 1, 2, 3, 4, 5, like 6. You have like a OH, something similar to this, but I don't know the exact. But I'm just saying that this is how the structure would look. Like it's just lots of carbon, hydrogen, and OH groups. So it is like polysaccharides, they are like molecules which have lots of alcohol groups on it. So that is why if we represent it this in the exam, we can just go, instead of writing out everything, but we have to say like, let this represent glucose, right? OH, we can plus because in reality, in the exam, they just want to know, to show that you know how to, that it's a condensation and that water is formed and what you remove. Alright? So, and again, if two alcohol is reacting, one alcohol at OH will be lost, another one at hydrogen. So it's no fixed stuff. Alright? But whatever the case may be, alcohol, water will be a byproduct because it's under condensation. So O that's the unit for polysaccharide. So they're actually easier to do in the exam because they're just going to say let this represent glucose and then just show it as that. Right Parks, right McFarlane? Yes, so good. Good. So they are bulky molecules, but you have to state in the exams we are going to let this represent it and break it down. Alright? So I've given you a hint of some of the uses of polymers, but you can go and do further research and reading on uses of polymers and also the impact of synthetic polymers, jar plastic, and the environment. I'm giving a hint here and there of the answers, but you have to do a comprehensive reading from the internet or a textbook with more details than the concise to have a comprehensive understanding. So in case in the exam you can make proper paragraph and write stuff on it if required. Alright?